Hi everyone. So in this video we are going to talk about SQL joins, its types with the help of examples. So let's get started. So you guys have wondered how to combine data from multiple tables in a database. So this is all possible with the help of SQL joins. So SQL joins helps you to combine rows from two or more tables based on a related column. And this is essential for relational database management and querying data efficiently across multiple tables. Let's now talk about the types of SQL joins. So the first type is the inner join. So as we can see from the diagram, it returns rows that have matching values in both the tables. The second one is the left join. The left join returns all the rows from the left table and the matched rows from the right table. The third type of join is right join. The right join returns all the rows from the right table and only the matched rows from the left table. The fourth type of join is full join. It is also known as full outer join. The full outer join returns all the rows from the left table as well as all the rows from the right table. Now the fifth type of join is self join. In the case of self join, the table is joined with the records of itself. In that being said, the table is matched with the same table. The next type of join is cross join. So in the cross join, all the records from the left table are matched to each and every record of the right table. So that's all about SQL joins. So let's now understand each join in detail. So let's understand the inner join. So the inner join, as we discussed, that the inner join returns records that have matching values in both the tables. Let's now look at the syntax of the SQL inner join. So in the syntax, we will be retrieving the columns that we want from table 1. Then we will use the inner join and we will write the name of our table 2, and we will be joining it on a certain condition which is the common column in both the tables. So the table 1 dot common column is equal to table 2 dot common column. Let's understand more with the help of an example here. So here we have two tables. One is the employee table and the other one is the department table. And the sample output is the output of the inner join between both the tables. So in this table, in the employees table, we have three columns, that is the employee ID, employee name and the department ID. And the department column has the information about department of those employees with the two columns, department ID and department name. So in this table, we can see in the inner join, we can see that it has only returned the records that have matching values in both the tables. So we can clearly see that the Alice with the employee ID 1 has department ID 10 and it matches with the HR department in the departments table. Bob, whose department ID is 2, has department ID 20 and it has been matched with the IT department. Similarly, Charlie with the department ID 3 has employee ID 3 has department ID 30, which matches with the finance department. Similarly, David with the employee ID 4 matches with the HR department. Eva with the employee ID 5 has department ID 20 and which matches with the IT department. Now we can see that Frank the employee ID 6. Frank with the employee ID 6 is not included in the result because his department ID is null and has no matching department in the department table. Similarly, the marketing department is also not included because no employee has department ID 40. So I hope the output of the left join is clear. Let's now get straight into the left join. So for the left join, it returns all the records from the left table and the matched records from the right table. And the result is null from the right table, from the right side if there is no match. So let's take a look at the syntax of the left join as well. So from the syntax, we can clearly see that the syntax is very similar to the inner join. We just have replaced the inner join with the left join here. Let's understand with the help of the same example that we discussed in the case of inner join. So here we have two tables again, the employee table and the department table. In the employee table, we have three columns: employee ID, employee name, and department ID. And the department table again have two columns: department ID and department name. And we have performed self join, and this is how our sample output table looks like. So in the sample output table, we have three columns. One is the department employee ID and employee name and department name. So in the left join, we saw that we have taken all the records from the left table and only the matched records from the right table. So here our left table is the employees table and the right table is the department table. So let's understand more in detail. So for the employee name Alice, it has the employee ID 1. It has department ID 10 and the department ID 10 matches with the HR department. Similarly, Bob has employee ID 2 and has department ID 20, which matches with the IT department. Charlie, which has employee ID 3 and the department ID 30, which matches with the finance department. Now David has department ID 10 and the employee ID 4, and it matches with the HR department. Eva with the employee ID 5 has department ID 20, which matches with the IT department again. Now if you take a look, Frank has department ID null. Frank has department ID null, so his department name is null, which is shown in our sample output table, because there is no matching department for department ID null. One more thing to note, that the marketing department is not included because the left join focuses on all the rows from the employee table regardless of matches in the departments table. So that's all about the sample output, and I hope the left join is also clear to you. Let's now get straight into the right join. So in the right join, it returns all the records from the right table and the matched records from the left table, and the result is null from the left side if there is no match. Let's now take a look at the syntax of the right join. So the syntax is again very similar. We have just replaced the right join here based on our join type. Let's understand the right join again with the help of the same example of employees in departments, which shown the sample output of the right join. So in the sample, when we look at the tables, the employee table has 3 columns, the department table has 2 columns, and then we have made the right join, and then we will see how it is done. So when we see the employee name Alice with the employee ID 1 has department ID 10 and it matches with the HR department, as we can see here. Now Bob with the employee ID 2 has department ID 20, which matches with the IT department. Now Charlie, which is the employee ID 3, has department ID 30, which matches with the finance department. David with the employee ID 4 has department ID 10 and it matches with the HR department. Eva with the employee ID 5 and department ID 20 again matches with the department ID. Now Frank is not included in our output, as we can see here. Why? Because his department ID is null. And when we talk about marketing department, the department ID 40, is included with null values for employee ID and employee name here, because there are no employees in this department, and since we had to retrieve all the records from the right table, we have done that. So in this output we can clearly see that we have retrieved all the records from the right table, that is our department table, and only the matching records from the left table, which is our employees table. So since marketing, this department name marketing was not present in the employee table, but we had to consider in our output, since we have to consider all the records from the right table. So we have placed it here with the employee name and employee ID as null, since it does not have any matching values for the employee ID and employee name. So I hope the right join is also clear to you. Let's now get straight into full join. So the full join returns all the records from the left table as well as all the records from the right table, irrespective of anything, like records from the left table without a match in right table, and those from right table without a match in the left table will be included as well, with nulls in place where the match is missing. Okay, so let's go to the syntax. So this is our syntax, but one thing to note that this full outer join syntax will not work in MySQL Workbench, because MySQL Workbench does not support this keyword, which is full outer join. And to join this, we will be using another method, that is union, and that I'll demonstrate it further. Now let's understand with the help of example. So in the example, we have considered the same example with the employees table and the department table, and full outer join gives us all the records from the left table as well as all the records from the right table. So from employee ID 1, 2, 3, 4, 5, we can clearly see that it has records with the employee ID, employee name, and department name. But since we have taken the employee ID 6 as well, since we had to take everything from the left table as well as everything from the right table. So for the 6 we have Frank null, and also for the marketing we have taken with the employee ID name, employee ID null, and the employee name is null. So Frank with the employee ID 6 has department ID null, we can see here. So his department name is also null, and for the marketing department, department ID 40 is included with null values for employee ID and employee name, because there are no employees in this department. So that's all about full join. Let's now talk about the next join condition, which is our self join. So self join is a regular join, but the table is joined with itself. So this can be useful for querying hierarchical data or finding relationships within a single table. So self join is useful in a case when we have to consider the same table to find the output. For example, consider scenarios when we have to find the employees that report to certain managers, or those kinds of situations. We use self join. So let's take a look at the syntax of the self join here. So when we talk about the syntax, we will be writing our table 1 and giving it some alias. Again we will be writing the same table, because we will be matching, we will be joining the same table to itself and giving some another alias, and then we will just match it on a common column. And this is how our syntax of self join will look like. Now the next type of join which is the last type of join is, which is our cross join. So in the cross join, it returns the Cartesian product of the two tables, which means it returns all the possible combinations of rows from the two tables. So this type of join does not require a relationship between the tables, and it can be joined even without holding any kind of relationship. So let's understand the syntax of cross join here. So here we can simply write the table 1 and cross join table 2. So I hope this is clear. Let's now all the types of joins are clear. So let's now understand and implement the same example in MySQL Workbench and see how joins works and how we write SQL queries based on join types. So guys, let's write SQL queries for each join type in MySQL Workbench. So here I have already imported both the tables, the employee table and the department table. So let's run this and see the employee table. So in the employee table, as we discussed, we have three columns: the employee ID, employee name, and department ID, and there are 6 records. Uh, and for the department table, let's run this code and see. For the department table, again, we have 2 columns: department ID and department name, and with the respective values. So let's first perform the inner join. Let's perform inner join. As we discussed on the syntax, so I'll just write select, and my first table is the employees table. So I'll write my table name here, and I'll give my table name as alias employees as E. And since I'm doing inner join, so I'll just write inner join. And my second table is department table, and I'm giving it as alias D. So the one common column is the department ID. So if we run the employee table, we see the department ID is there, and for the department column again we have the department ID. So this is the only common column that we have in both the tables. So we will be joining these two tables on department ID column. So E dot department ID is equal to D dot department ID. And now the columns that I want to retrieve, I'll write here. So I want employee ID, employee name, and department name. So the employee ID, I want it from my employee table. So I'm writing it E dot employee ID. Next, I want employee name. So it will be employee name. And the third column that we want is our department name. So D dot department name. Sorry, department name. Cool. So I'll run the query and see what it gives me. So it has given me the same output that we actually discussed. So it has given me only the matching records from both the tables. And see here, we have got the employee ID with the employee name and the department name, which were already mentioned in both the tables. And since we know that the Frank with the employee ID had department ID null, and we can see that it is not included because it was not present in the department table. So that's all about inner join query. Let's now write for the left join. So left join. So the syntax is merely the same. We will just replace it with the left join. So I'm just copying it. I don't want to rewrite it again. So just ending the first query with a semicolon so that it does not shows any kind of error. So the left join, and since I want to retrieve the same columns, so I'll just run this query. Okay, and now we can see that we have got all the records from the left table and only the matching records from the right table. the Frank with the null department name. So that's about the left join. Let's now see for the right join. Right join. I'll make use of the same query with the, just replace the left join with the right join, and it will give me all the records from the right table and only the matching records from the left table. So that's about the right join. Just performing it here. So since we got that marketing department had the no respective employee ID and employee name, so uh, we have replaced it with the null, and this is how the right join has worked. My last join type is full outer join. So since I had already mentioned that there is no such keyword as full outer join in MySQL Workbench, but if you work in an Oracle database or any other database, you can directly use this keyword and you can just run your output. But if I do that in MySQL Workbench, I'll get an error. So I'll do it with the help of union condition. So what I will do here is I will first output the records from the left join, and then I'll output the records from the right join, and then I'll just do the union. So it will give me all the records from the left table, all the records from the left join, as well as all the records from the right join, and after merging them I will get all the records, and that will be same as the full outer join output. So what I'm doing here is I will just write for the left join and for the right join, since I don't want to write it again. So since this is for the left join, this is for the left join, the same, I'll just copy the same, and in the middle I'll do union. So union will actually uh, merge the both outputs. So there is some error here. Okay, I have to do semicolon in my last query. Fine. So this has to be right join, right join. Sorry guys. Okay, so this is the query of my full outer join. So let's now run this query and see the output of the full outer join. And in the full outer join, for the output, let's make it bigger. Yeah, so we can see that we have got all the records from the left table and all the records from the right table. As we discussed, the sample output is actually it actually matches with that real output here. So that's all for the SQL joins. I hope you are very clear with the SQL join types. So that's all for this video. We will separately discuss self join and cross join in a separate video that I will probably make in future.